Hello everyone. In this video, let's discuss problem 3 of Biweekly contest 149. This was the part 2 of like this second question. Uh, there were some minor difference. Let's read the question. You are given an integer event time denoting the duration of an event. You are also given two integer arrays start and end time, each of length n. Okay, same as it was like there is some event happening from 0 to event time, and we have some meetings like start time, end time denoting n meetings. These represent the start and end times of n non-overlapping meetings that occur during the event t equal to 0 to t equal to event time, where ith meeting occur during the time start time and end time. Yeah, that is what the question is saying. You can reschedule at most one meeting by moving its start time while maintaining the same duration such that the meeting remain non-overlapping to maximize the longest continuous period of free time during the event. Return the maximum amount of free time possible after rearranging the meeting. Note that a meeting cannot be rescheduled to a time outside the event and they should remain non-overlapping. Note in this version it is valid for the relative ordering to change after reschedule. So if we compare with this previous problem, this problem says like here we were allowed to change k at most k meetings. Here we are allowed only to change one meeting, but the main thing change from here to here is here the relative order was maintained, but here we need not. The relative order can be changed. So one meeting need to be starting time of one meeting need can be changed so that we should maximize the free time. So if you see the example one, so this is the maximum we can have is to move this to either left or right. So two blocks would be free. If we have this sample, so these samples, if we move these blocks between these two blocks, like 8, 9, the maximum we have is 7 unit of time free. So which is the maximum where any other would be like to move this block just after the green block, then we have maximum from 2 to 9. If you are moving red, then I don't think we can have maximum free time. In third unit test case, the maximum would be to move orange block between yellow and red block. So that the maximum we have is 7 minus 1, 6, which is the answer. Fourth example, meetings are contiguous and event time is duration of event time is equal to the duration of the meeting, so it is 0 here. So that was all for the question. So to solve this, uh, as I discussed in last video, suppose this is our time axis and we have some event t up to t, and suppose there are some four meetings happening. S1 E1 start time in time, S2 E2, S3 E3, and S4 E4. So here we are given at most we can have like K1 or 0 means if it is 0 then the answer would be like we are not moving any of the meeting, the answer would be the max of these gaps. So whichever gap like is maximum which would be our answer. But if k is 1, then as if we have to maintain the ordering, then we can move one block either to its left or to the right. So the answer can be maximum of like moving this block, the duration would be from this to this and the duration of this. So it would be, so suppose there is a one block here, if of time duration 0, let's denote S node denote, and there is some ending meetings S and En just to simplify the like calculation. So here the answer would be S2 minus E naught. Total duration is this much. We will subtract the duration of meeting 1. S1 minus S1 minus E1. For M2, similarly, it would be the total duration would be here to here. It would be S3 minus E1 minus duration of meeting S2 minus E2. Similarly, we can do from this and this. This was like Q2, question 2. The main thing here is we need not have to maintain the ordering. Here we are maintaining the ordering, like we are moving only left and right. We are not skipping any of the block. So if you want to speak, like remove this block and add somewhere else, like no need to maintain the order, then we can do only when there is some block, like let D1 be the duration of meeting one. So there should be some blocks which free time like would be greater than equal to D1. Then only we can move this block and add here, accommodate here. Then our like free time would be like direct S2 minus N0 from here to here. So for every block, first uh, we will maintain one set. Okay, there we will enter all the free blocks that we have available to the blocks F1, F2, F3, F4, F5. Then for every block we will check is there any free blocks available. Like we will first subtract the blocks available to the left and right because we want to move this block out of here and here, like out of somewhere else. Otherwise, the solution would be the same, like subtracting duration. So we will subtract from set like here. For if we are calculating answer for M1, then we will remove F2 and F1 and F2. Suppose this is F1, F2, F3, F4, and F5, and we'll check like is there any blocks which can accommodate meeting one. So here, if suppose F3 was some dead block, then we can like remove this. So our answer would be from here to here. Like this, we can check for M2, then for M3, then for M4. So answer would be the max of all those possibilities. So that was all for this. Like you need to be good in implementation to solve this problem. So it was not that difficult. You just have to implement properly. So going to the code, like I had one vector of pair to combine start and end time. 10 is the size of total number of meetings. I have multi-sets because duration can be duplicate, so I have multi-set instead of set. I pushed all free block that I have. So first block is not starting from zero, then first free time will be start time of zero. So answer could be start time of zero, or from zero to n minus one, the free time would be start time of I plus one minus end time of I. Like start time of E2 free time we can calculate is S2 minus E1, like start time of I plus 1 minus in time of I. So I have answer max of whatever difference we are getting. So this up to this the answer will be having values where k is 0, like we are not moving anything. Now if we want to move, so I will calculate the duration of the meetings like in time minus start time, and I will remove the before and after blocks as I explain here. If I want to calculate from M1, I want to remove the block present here and present here. So before would be start time of I. If I is 0, then if there is before anything that is start time of I. Basically, for I equals to 0, the free block would be the start time of I. Or before, if it is not the first block, then it would be from start time of I minus in time of I minus 1. Start time of I minus in time of I minus 1. So if it is non-zero, then I will remove from my set. Similarly, for after, if it is the last element, then the free block would be time, like event time minus E4, like last element in time. Uh, where is it? In time minus event time minus in time. Otherwise, it is start time of I plus 1, like S4 minus E3. Like if you are calculating for this, the gap is I plus 1 start time minus current in time. So start I plus 1 minus in time. I remove after also. I remove before and after. Then I use lower bound to check if my meeting duration is some blocks can accommodate my meeting duration or not. If it can accommodate, then my answer would be the complete, like I will remove and complete duration would be my time. So if it is the first element, then like from 0 to I plus 1, like till this, the whole answer, I will remove this block, so whole free block can be my answer. If it is the last element, then removing this, so I minus 1 in time to event time would be my answer. So event time minus in time I minus 1. Otherwise, removing M2, then start time of I plus 1 to in time of I minus 1. Start time of I plus 1 to minus in time of I minus 1. This would be answer if my block can be accommodated somewhere else, like current meeting can be accommodated somewhere else. If we can't do that, then we need to subtract that. Like we can just move that block left and right. So we need to subtract the meeting duration. That would be my answer. So that will that we have in ans maximum. So maximum of these two cases like would be my answer. Whatever we remove here, like erase here, I will do reverse, like insert again to check for the remaining answer. At the end, I will return the answer. So that would be my solution for this problem. So yeah, that's all for this video. Like if you like, please like the video and subscribe the channel. Give me motivation to make more videos. Any doubts you have, you can ask in the comment section. I will be more than happy to reply you back. Yeah, thank you everyone.